I'm Tero Laine from Dauko Technology Services. I'm here more as a technology consultant and as a workflow consultant and platform provider. And here I have the honor of introducing Adam Pavkiewicz and James Tapper from KGS. And Adam's role in this is more like a BIM coordinator, 3D model coordinator, and James Tapper was then the application specialist and implementer. So we were asked to, or CanVim Council was asking whether there are any presentations available for BIM projects in Winnipeg. And this is something that, of course, rang a bell immediately. The recent Manitoba Hydro project, which KGS was doing the detailed design and construction models. And if you have any questions, I also have to introduce Paul May on the back seat from Manitoba Hydro. As if you have any questions, then towards the end about how owner and owner sees the benefits of BIM and requirements for BIM. So let's talk a little bit about the project. Then I'm gonna let Adam now continue.
Unfortunately, our presentation is a bit more of an engineering presentation and not nearly as nice as that beautiful polished architectural presentation. Our end project is a little less glamorous. It's a spillway. Same order of magnitude cost as that project, and in hearing him talk about it, it's almost all exactly the same design challenges as you go through this. So I'll give a bit of background on KGS Group. I'll say we've been in the BIM market since long before there was the terminology BIM. We've been doing parametric modeling and spec-based modeling and modeling for lots of our larger projects. Mostly is it related to industrial clients. So as you get into oil and gas and large piping and process, the concept of it must be modeled, we want the model at the end, the model's got to be spec driven, the model must contain the information we want because we're going to use it later. That is old process for us now. But as we're getting into the hydro world, hydro is still very much like architectural was a number of years ago, where they were so large and so developed in the 2D world that they worked very much in the 2D world for a very long time. So this spillway replacement project was a bit of a pilot project where KGS came on. We looked at a number of different options for how are we going to do this, because Hydro wanted us to look at this. And most of what we had done in the hydro world had been in the 2D environment. So as KGS Group, we only have a number of offices only in Canada. We didn't do a lot of this design in other places around Canada. Most of this was done right here in Winnipeg. We have about 250 staff here in Winnipeg, and a large chunk of people were working on this project. I'm actually just going to switch to the project description itself. So this project was a large earthworks project and civil construction project. So concrete and rebar and some steel. And in the previous project, you saw it was difficult to lay up the wall at a slant. When you're talking a spillway, you have all kinds of pier noses and OG crests and all these fancy swooping shapes that traditionally were just very difficult for us to model. So even though we've done this in other environments, this was the first time we were actually able to find tools that could approximate that stuff for a hydroelectric project. So if you look down just in this little corner here, the bulk of this work takes place right there. There is a pile of concrete and rebar in this structure, and then this piece here is all a large earthen structure. So in this project, much like last time, we had lots of different technologies we had to use. We had to look at something that could do the concrete and rebar, was from a different vendor from something that could do the earthworks, was from a different vendor from something that could handle all the point cloud, was from a different vendor from what could do the M&E. And in the end, same way, we all tied it together with Navisworks and did some of our final clash checking and things like that in Navisworks. So in here, we ended up using Civil 3D for all the earthworks. The really unique piece for us here was actually using Tekla on the concrete and rebar. Even though lots of this looks simple, the rebar mats inside these structures are typically 1 inch to 1.5 inches reinforcing. that's 6-inch mats, so it's spaced 6 inch apart, and there's usually multiple mats of that. So anytime, if you just want to put a conduit through the concrete, you suddenly have to reform a whole bunch of rebar just to get through there. Or if you want to put gates in a structure, all the anchorages and everything, they get very complicated. So this project started in 2010. We did a preliminary plan for how we were actually going to do the 3D modeling. And there we went through the actual client requirements. And that line there, be as BIM as you can be, that's Tero's line on it, but basically the challenge from Hydro was, tell us how we can model this thing in 3D and actually put that parametric data in. And like I said, up until then, it hadn't really been done with large-scale concrete projects. So that was our challenge, and we had a project just to plan how we were going to do this. So I don't know if there's anything else you want to add to that, Tero?
No, not from my side. Not from my side.
Well, so identifying required changes in the workflow. This is something that was always fun to talk to people. People would say, okay, so when do I get to look at the drawings? And to a certain extent, we were up against that challenge all the way through. But we did regularly go through model reviews, but through this whole process, we still did generate lots of drawings. So one of the things we needed to look at was, how can we use the model to generate information that is useful drawings for all of the people to look at. And then design tool upgrade process. How do we switch from our environment right now, which is basically flat 2D, AutoCAD, one color, line weights, to a 3D environment for Manitoba Hydro. And that was a bit of a challenge at times, and sometimes it was easier than you'd think. For the younger members of the design team, switching to a 3D tool was pretty straightforward for them. For some of the more seasoned veterans who've been doing hydroelectric design for 20 or 30 years, switching to a 3D tool was a bit more of a challenge. So you'd often have the modeler sitting at his desk working, and then you'd have the guy standing over his shoulder saying, now show me this, okay? Now show me this. So that was kind of part of the design tool upgrade, but once we got there, then we had a fully implemented kind of a 3D modeling tool. And like I said, Tekla itself was what we used, but we had to make quite a few tweaks to get it to present the information the way the clients wanted. I'm actually just going to jump down here in a couple of pages so you can see. This right here is a bent bar schedule. So it tells you, what are all the bars in my structure? How big are they? How are they bent? How are they formed? Seems like a relatively straightforward piece of information, but when you've got hundreds of tons of steel, generating this in some kind of an automatic fashion is incredibly complicated. So we had to go through and do a number of modifications to make sure that we could get the deliverables that the client wanted. Software evaluation training, like I said at the beginning of this, we went through a whole bunch of different softwares just to see what we could do. We had a simple test that we would give to the vendors. We would give them a block with a one side slope in 2 dimensions and see if they could model it and reinforce it in a reasonable fashion. And most of them couldn't. So that was kind of our pass-fail on our modeling tools. It sounds like you had that same challenge. In the end, we did find something that could. It would also do curved surfaces and sweeping surfaces, so in the end, we were okay. The interesting thing too, software evaluation and training, some of the modelers we had on this project were brand new, not just to modeling, but to the industry. So they went from knowing very little to being fully operational kind of designers, operators in a very short period of time. So that was nice for us. And then this new model-based workflow, model governs, design follow. Like I said, that was one of the challenges that we had all the way along, where If you were from the old school, you said, great, where are my 30% drawings? And we'd walk them a bit down the path and say, well, here are the drawings, but join us for this WebEx model review that we're going to have every couple of weeks to review where the model is, and we would walk them through that. And by the end of the project, people would look more to the model than the drawings. So I think we got lots of words here at the beginning and not a lot of the pictures, but maybe I'll talk to this a little bit and then we'll get through kind of some of the specifics. Benefits related to thinking and delivering real construction level BIM. One of the challenges that we always have is our deliverables ultimately aren't just the drawings. Our deliverables are what's built in the field. So for us, real construction level BIM made us think, what changes in the drawings? Are there different kinds of deliverables we can give? Can we give machine controlled things? Your structural steel you were talking about was fabricated right in the shop. I think Walter's probably used Tekla as well to do most of that modeling. And that is the same software we use to do most of our concrete reinforcing and structural steel. So better quality of deliverables often means the deliverables change a little bit. So we needed to sit down with Hydro that has very strict drawing standards, drafting standards, all that kind of stuff, and say, how can we make these new deliverables still try to fit your system? Luckily, Hydro had a little bit of flex in this project, as it was a kind of a pilot project for how they were going to work going forward with BIM, and that they would allow some things to vary. We were given some grace that our deliverables didn't all have to meet the same level of microfilm requirements, which is kind of funny when you think about it in terms of what you're doing. Like when you're talking these kinds of 3D models, and then on the other side of the conversation you're saying, how do we microfilm this? So that was kind of interesting. Models are now standard communication tool. Same thing, we would export a Navisworks model pretty regularly during the design, and design was ongoing well into the start of construction. So we would publish that out, and they would look at that on site, they would look at that at the clients, they would look at that at the contractors. Different people would look at different complexities of models, so we would publish out many more iterations of some of our backup model information if people wanted to use it. But most of the time people worked at Navisworks or BIM site. This was kind of the big challenge we had going into it. All cast in place and precast concrete, steel, rebar, and formwork, modeled in the same model. And we were able to do that, which was a big challenge for us. So this is just some simple shots of the model. You can see it's fully populated with rebar on the inside. And again, these bars are typically 1 inch in diameter, so they don't just bend out of the way if we need to swing something through them. All the deliverables we got straight from the model, so all drawings came from the models, concrete volumes, bills of materials, so all those bent bar schedules, all of the custom steel fabrication, all of the connections, formwork areas, rebar bending schedules, BIM site model, and lots of our analysis models were exported straight from our structural model for direct analysis. So that was a big advantage for us. Just to give you an idea how flexible some of this stuff is too, this project changed midstream because of some regulatory issues. We were able to go from 2 spillways to a single spillway with more bays, and we were at a fairly high level of drawing at that point, and we were able to turn that around in about a month to the new drawings and all the new structures. So that was a big change for us. Significant reduction in interferences on the job site. I think Tero originally had 0 in here. There really is a huge reduction of interferences on the job if you talk to the industrial clients, you'll see that it's about 10% rework to about 2% rework when you start talking what you're modeling being fabricated off-site and arriving and assembled compared to being field fit. Once things are field fit, there's torches, things cost a lot more, stuff just doesn't line up. There was one call we got on site because one of our bent bars didn't fit, and it turned out they made a template of what it should have been. They brought it out to site, and the bar was bent incorrectly. So all of the rebar, we didn't get any of the calls back at the office that said, hey, this rebar doesn't fit. What are we going to do? And when you've got hundreds and hundreds and hundreds of tons of rebar, that's a big deal. Some of the problems that didn't happen because of the detailed models, elevations and dimensions on drawings. Sounds like for the museum, lots of times you would go to the model, and we would have liked to, but we still had the large civil contractors. So if you could just speak your mic a little bit. Large civil contractors are still mostly liking to do certain things on paper, and dimensions is one of those things. And these guys use the model for a lot of stuff, but in the end, typically what we would do is, because all of our drawings were parametrically tied to the model, we would just say, okay, we'll just add that dimension to that drawing. And it wouldn't be difficult for us because it was accurate. So everyone was much more confident that what they were seeing in the drawings was going to match what they were supposed to build, and that it worked. So this, again, looks pretty straightforward. That's what it looked like actually on site probably a few months ago. So just to get some scale, I believe that's a person standing right there. So this is piles of rebar and lots of concrete, and this model was tied to a Primavera model to be used for, again, 4D construction. So the contractor took this model and they tied all the pours and all the sequencing and all the lifts together to go over how they were actually going to build this, because to build it in a reasonable window is also a challenge. Just to show some of the level of detail in the model, all of the steel, all of the concrete. What's that?
Yeah, I was just meaning to mention that Cages even went through the trouble of the chains.
These are where you get into things that you maybe don't want to model, but we do have chains across here. We do put the chain falls on because it is still welded to the piece of steel and it does get fabricated. This is where you need to get very careful with how much detail you put into the model. By this point we were already pretty careful, so that was probably the only thing that had a high level of detail on that, and it was only there because it was welded to the pipe. But in previous industrial projects we've had guys model fins on motors because, you know, they can model the fin and array it around, and they think that's just great, but when you have a couple hundred motors in an industrial plant, it starts to really bog down a computer. So this is also gives you some sense of the amount of rebar in this project. This is a section through a spillway. Again, this shape here and the nose of this pier are the things that turned this from a project where you could pick a concrete package that can do slabs and beams and columns into something that needed to intelligently reinforce along surfaces. And I guess some of the other things to look at here, all of the different ability to adjust these hook lengths and then call out these pieces of rebars to standard bent bar schedules was really a bit of a boon for us to get working, and incredibly difficult. So you have just a simple look, even inside this is a bar, this is a bar, this is a bar. Now these bars, it's developing up between several pours, so you need to figure out how is this going to go in. So bars were associated with different pours, so you could see when bars needed to be placed. even this stuff here, this gray line, there's a whole pile of water stopping that goes into a structure like this that's holding back water. And the complexity of weaving that water stopping through and making sure you have a continuous water barrier between all your pores, it's incredibly complicated. So here again, this was a base pour. You can see in this base pour we have a whole bunch of rebar developing up into these slabs. This here is about 3 meters. So if you had a person standing here, he'd be not as tall as this OG crest. And, you know, in the end, we still have a lot of traditional drawings that everybody wants to see at the end. And these are what get microfilmed. Because they are, well, by the tail end of this project, they finally agreed to use PDF as their basis of deliverable. But when we planned this, ultimately everything that they wanted to keep long-term was going to get microfilmed. So maybe I'll get James to talk about this a little bit, because it gets into some of the details for rebar checking and things like that.
Can I ask a question?
Yeah, I'll let. So it's a bit more informal, our presentation.
One thing which I wanted to kind of maybe James also elaborate a bit, like you said, Adam said how people who actually do the models were new in the industry. They didn't know modeling, they didn't know even drafting properly. And James, can you tell what kind of process was it to actually get KGS into 3D cast in place steel and precast concrete models? How many modelers did you train? How long did it take for them to actually, how difficult was the job?
Yeah, well, like with any new company, you're going to find, you're going to have obstacles, right? Developing a new software package. You guys all know the same story. Initially, we tested a few different packages, as Adam talked about. After we did the evaluations, we decided to go with Tekla Structures, and then initially we had a team of steel detailers that had been using Tekla Structures for quite some time. Nobody had been detailing concrete rebar utilizing Tekla, so we took a number of people, some that had actual...
Can you use my guy?
Sure, sorry about that. So we took a number of detailers that we had that had done, some AutoCAD drafting and a few other applications, and began teaching them how to model concrete rebar with Tekla, which was, although the shapes are quite complex, there's obviously some obstacles, but it's relatively simple to model these concrete shapes in Tekla. So
Most of the modeling in this project was done by 2 modelers for the cast in place concrete.
yeah, and essentially they had a 3-month crash course on Tekla, and it wasn't a matter of this is how Tekla works, this is the project, let's get going, and that's how it developed. But successfully now. I mean, at one point not long ago, midway through the project, those 2 modelers had essentially taken over the project and are very well versed at this point, ready to take on the next project.
Now, James makes that sound easy. At the beginning of this project, we had to do a fair amount of thinking, and we built a complete sample model in the planning stages just to make sure that we could go from 3D model to flat drawings to rebar schedules that can work to poured concrete surfaces, because we had been through this same kind of thing before in the industrial world, where it looks like we have the tool, but we needed to prove to ourselves that the tool would get us from the beginning to the construction deliverable. And luckily, Hydro was on board with us actually going through that process and went through it with us. And that was a benefit that most people don't have. Typically, when you start with a 3D tool, you'll get a client that says, okay, we'd like to do this in 3D and we'd like you to start tomorrow. And we don't know what we want in the end, but I'm sure you can do it just fine. And unfortunately, there needs to be a lot more interaction between the client and the consultant. And in this case, we had some early contractor involvement too, so we were able to go to the contractor and say, hey, which of this stuff can you use? Which of it can't you use? There were a few things that they probably could have used, but because of how we had contractually set up the arrangement, they didn't use in the end. Some of them were, we could have done pour by pour drawings, but at that point, the contractor was already in, and they had a certain level of responsibility. So if we did that, then we would be taking on some of their responsibility. So again, talking about the legal contracts and things like that, understanding where in the process people are taking responsibility is also very important, alongside of what you can do with the tools.
Yeah, so one of the things which, when we talk about building information modeling, is the amount of information in the model, and it's not only about making the drawings out, but like one of the things KG is used as part of it, like people check drawings often at the moment. So in this case, it was more about checking the model. So they went, for example, through, I'm not sure whether it was Rebar by Rebar, but they checked what's the shape, is it the right shape, and then they actually stamped it. And there you may see that whether it's released or not. And this information is then stored to the model as well, like what kind of checking procedure there is. So there's not only drawing coming out, but the model actually can contain lots of information usable for other people and even inside company when you are tracking down who did what, when, how, etc., etc.
It is important to note too, the process that we did internally at KGS for developing the drawings was very much one of checking. In handing over the model to the contractor, in this case, the contractor wasn't using the model technically for construction. Their contract was tied to the 2D cuts from the model. But they always had the model, so we were always keenly aware that whether the contract is tied to it or not, they're likely going to be building from it. So we still went through a very thorough process of checking the drawings to the model, and that gave us really our secondary check on the model itself to make sure that we knew that the model was correct. Because one of the things that we've learned over time is that while the drawings are less derived from lines, they're still very important as a designer's interpretation of what that building should look like. So as long as you can always get to some good models and some good drawings in the end, the drawings are effectively the thing that you use to check to make sure that what you've built in the model is what you expected to build. Does that kind of make sense to people? Or am I losing everyone with that part? Okay, so often we would use the drawings as a checking tool on the model, but we would check the model first. So at the end, we knew we were 99% of the way there, and then when we cut the drawings and we did a back check, we knew we were 100% of the way there.
And one reason to check, focus on or having the model to check benefits the process, because when you are, for example, when you are checking rebar, whether it's right or whether it's concrete, you check it in the model once. It doesn't matter if it's visible in 1 or 100 drawings. If it's right in the model, it's always right in the drawing. So this way, building information modeling can really make your work much easier. And because the drawings are actually just they are used to the model, so that first was probably like, is this really true? So that what you see in the model is actually what you see in the drawings. But that's the way building information modeling works, and I guess it's supposed to work as well. And like here in this case, I think part of the kind of new thinking process was identify, like there was, I remember being involved in discussions what are different rebar shapes and how they are defined, like this particular software does have automatic rebar shape recognition, but they wanted to always kind of track down what are the actual, is this really how it's done, because it used to be done basically manually. You wrote
I'll give some background on that just quickly. Historically, bent bar schedules there's a set of standard bent bar types, and you would give the type and all of the standard dimensions to that type, and you would develop that completely manually. We could already get bent bars with precise dimensions, but because we needed to get bent bars with precise dimensions and match types, we custom built some macros to identify the type in the bent bar and draw it up in accordance with those standard shapes. It's a bit of an interim step that I think in the long term of BIM if I have a bent bar that has one leg that's 100 millimeters, one leg that's 1,000, one leg that's 50, that's likely what the information I'm going to give, and I'm likely going to give it digitally. But in the short term, while people are transitioning from this is the way I used to do it to this is what my model can give me, these are some of the interim steps that we have to do so that we present it the old way from the new information. So, what else?
Well, there are a couple of more samples of the quantity tables, like this is very simple process probably in the past, like count million pieces of rebar and how much do they weigh. And by utilizing building information modeling, this is literally, eventually it's a click of a button when you have the models done.
So there's half a million kilograms of rebar.
And if KGS had to rebuild the project, well, not rebuild, but to make some severe changes to the project, all these, when they were changing the models, all these quantities are automatically correct. And this is something that I have from my background. I have talked with many customers who, just the fact that you don't have to calculate something manually, using Excel or using papers, that's a huge benefit then in the reliability of your deliverable. So you can actually trust what you deliver is accurate. And you don't have to go through that, did I take this change into account in this quantity takeoff? Did I forget it here? Did I forget it there? How did I end up in that 505,000 kilos of rebar? So that's something that is kind of the benefits of when you are starting to think more model-based. These are the things which are on your fingertips. And then I would like to, we did mention, unfortunately, contractor is not present today here, and there are certain things which are available in the model for contractors if they are allowed to and if they choose to use. So here are just few samples like what KGS did in the model. Like one thing is that they can, first of all, they can go to the model and they can ask how much formwork would I need for you guys. How much do you weigh? How much rebar is there in you? So that's something like, in addition to going through set of drawings, they can just go to the model and ask for that information. So that's the information in the model. It's the big I in the BIM. Then also making these models available not only to your direct client, but also make them available if contractually agreed, also to the site. Like these models are light enough to run on Windows tablets on site. And they can then use actually the same models, they can see the same models, they can see your comments, they can ask information about all the information what you have in the model is available for them in these tablet applications. They can also add their own comments, whether it's approval, whether it's questions, and this model can actually talk real time with the back office model, which is the real modeling model. So a little bit like Navisworks has been used for certain things, like this kind of free application actually can bring the site very close to the office and be a kind of communication platform. Even without WebExes, not to mention emails, you can type in a question like how is this going to be done, and whether it's the Manitoba Hydro answering the question, whether it's the contractor's back office, or whether it's the KGS and the designer himself answering the questions online and seeing the information, everything gets stored to the model. So it's about information. This project actually entered in the Teklas US BIM Awards, and it did win the concrete modeling category. Funnily, this is just a quick video which was done during the entry stage of those BIM Awards. Just so happens that same year, like Winnipeg hasn't really ever been a strong hub for should I say detailed building information models. That same year, the owner is staying. Yeah, another investors field BIM model won actually the steel category, but that was done. That was actually modeled in Quebec. But I'm going to skip this
I
video.
believe the Human Rights Museum was in there as a steel structure as well. So it was a funny thing. We were down at a conference in Florida, and there was 3 projects out of Manitoba. This one, the Investors Group Field, and the Human Rights Museum. We were lucky to win the award for this one for the reinforced concrete. Like I said, it doesn't look nearly as detailed, but once you get into the details of it, it was incredibly complex, just the reinforcing and the concrete itself.
So then, we have talked a little bit like what could have been done. So here are a couple of things which have been mentioned also earlier today. Like Adam and Chase mentioned, like they could have taken a drawing production quite easily, quite a bit further. Primavera link was mentioned, like they can. Often Primavera is like a skeleton of the project, and sometimes it's kind of heavy tool to be used on site, and these models can actually bring all the meat on that Primavera skeleton, because all these all objects in the model can actually be linked to the Primavera tasks, and then the guys who are using Primavera can actually rely on the same model information to control their invoicing and scheduling if they wish to do so.
As a note too, we did quite a bit of on-site laser scanning before, during, and after construction on this to plan the project, validate some things where we had some oddities in the larger pours, and just accommodate, lots of this was blasted into a big hole in rock, so dynamite being as precise as it is, sometimes there's little bits of overbreak and things like that they needed to accommodate for the design. So beside this was a whole layer of back and forth 3D information from site with the laser scan to not only design it, but validate the design and modify the design kind of as we went. So that was interesting to see.
And when it was identified that there was one rebar which was incorrectly bent, also that probably could have been avoided if like there's a longer history in steel structures to fabricate everything automatically and from the model. Same thing can be done with bent rebars. So there's probably in Canada there are dozens, if not hundreds, of rebar bending machines which can be driven from the same building information model. So in order not to get it only faster but also more accurate, so to prevent the human error in that process.
Yeah, interestingly, we went through quite an effort even here to generate a bunch of bent bar schedules and review a bunch of bent bar schedules, but the way our steel has gone, if we start modeling it straight in Tekla and we do the connections in Tekla, it basically goes straight to shop drawing, and then they fabricate straight from digital files. And we could do the same thing with reinforcing. We didn't do it in this case because I think people were still a bit wary, but it'll be interesting to see how that part of the industry goes. Because the reality is, if I can email you the files, and you can start running that rebar through those bending machines and have it shipped and tagged out to site, there's a lot of schedule advantages there.
And a little bit more about the kind of benefits which can be then driven for the contractor. And this is, again, I'm saying information, not only for designers to actually make their design work together, but something that design seamlessly integrates into construction. And like certain things which probably will be used possibly in the future projects. Here's a very simple foundation. So there we have by using colors we are identifying whether, like when we are splitting this into poles so that they are not too big. So everything which is too big is red, everything which is okay is green or less than maximum. So we can drop in those construction joints and create, whether we show them with model to the contractors, but also can make drawings of those. And this way kind of take that use of model a little bit further, a little bit close, even closer to the actual construction benefits. And then when we have something in the model, instead of going into drawing and checking how big my footings are, they can just go and spit the numbers out and whether they want to process them inside the BIM application or whether they want to export those to Excel and do processing there. So all that is kind of close by. And another thing is then when we have unlimited amount of information can be stored into these building information models, you can then actually start to very easily within the same application you can start to visualize, okay, how is this going to be built together? How does this work? How can I make it work on time? And how can I actually link all this information then again back to the Primavera, where it could have all the times and dates when even each concrete truck arrives on site. So building more and more information to these models is probably something that's going to hopefully also with CAN-BIM initiatives that's going to happen more and more. So it's not designers model, and it's not designers talking to designers only, but it's also designers collaboratively talking with, using models as a communication tool with contractors. And this was mentioned earlier, like this is becoming more and more popular nowadays because of affordability and also improved technology. Is the use of this not only you can not only import the information from site to for you into the model to build your model, but you can then also export the information from model direct to the site, and then not only hopefully put all the, like in this case, all the anchor rods finally on the right locations, but also get information back immediately if they're not on the right locations. So this kind of information flow from site to BIM is something that I hope that will be more and more visible in the future. So here there are a couple of things which I thought we have a little bit of time. So also to bring in Paul from Manitoba Hydro as a customer's point of view, Tekla administrator, BIM administrators, like finally, what did you learn from this project, and what did the customer get, and how would the customer actually, who is paying the bills, how would you like the billing information modeling to evolve? So, Paul, can you say a few words as a client? How did you see the new kind of model-based workflow work for you?
At a high level, there were some very basic benefits that we saw early on to doing things this way. Our projects at the conceptual level go through pretty heavy scrutiny from a lot of areas within our company. There's regulatory aspects, there's various engineering disciplines and construction-related disciplines that we put through quite a bit of scrutiny. So just the visualization aspect and being able to do this was a big help early on. We have some standard processes that we use to vet all of our construction jobs and particularly our major capital works through these departments, and we managed a lot of these reviews now through the model. Everything was during all of our reviews, all the comments, approvals, things like that were captured as comments in the integrated model here. And then getting to the construction phase of things, we just came off building another similar heavy civil job up north, and a couple things we've learned are that contractors can come up with some pretty innovative ways of using repeatability and certain construction techniques to economize on things. So we really took that sort of review process that we started with internally at a conceptual level and brought it to the construction world, and we had a different project delivery strategy with this one, where we brought in our contractor early for integrated design build project delivery format, and our main contractor and us as the owner and the designers worked together for a while to get some of those efficiencies in on the front end instead of having them bog down the construction process once we were already through. Again, that was all done using the model for visualization, and also using the information that came out of it for, I won't repeat the things that the guys here have already mentioned to you. So.
Just as one note too, probably something that I still don't know if we've pinned down what we're going to do. We did develop at the beginning a process to tie lots of our information in the model to asset management. We also develop a process for tying lots of the construction shop drawings and photographs and all that stuff into the Navisworks model. And so that stuff, because this job is just getting close to the end of construction, we're still not sure exactly all the paths that they're going to go down for that. Like was mentioned earlier, you do need to be a little bit careful when you get into this, because there is no end of things you could do. You need to figure out what are the things that are beneficial to the design, the construction, and the long-term management of that project. And if the things you're looking at doing don't facilitate one of those three, then you maybe need to look hard at those. Like, there's lots of stuff we could have done where we laser scan every surface and as-built every piece of rebar as it goes in and validate it back to the model. But then you would have to ask, and with all that heroic effort, who is ever going to check or use that information? And if the answer is no one, then you have your answer. So, anyway, that's just something that...
Can you go back to the questions there? I think you, when I was looking through them, I think you answered probably one of them. That's probably one of the main pitfalls that you can get into if you try to jump into it right away and just say, put as much information as you can in there. You really have to think of what the end use of everything's going to be. Probably to answer the first question, what would you not do the same? Continuing on with what we know now and how far we've come along during the execution of this project. We know a lot of things that in terms of asset integration, our asset, we have all our own operations and asset management. We left some open questions at the beginning and we said we were going to answer them throughout the course of this project. Now, we needed to do that because corporately we had never gone through this before, so we left those things open. Now nailing down exactly what you want for the end use of the model in advance is advantageous. I'd probably try to do that if you do know enough to make those decisions early on, because implementing things as you're going through construction, I'm sure all of you are aware, once you start building things, it becomes a very narrow focus in terms of what you want to achieve, and that's during construction. It's completing your project efficiently. So, well, what I definitely do the same way is the whole review process, the whole visualization of everything. You can bring someone who doesn't have a technical background, who can't take a set of drawings and sort of review it very efficiently. You can bring them into the process very, very quickly by using these visualization, commenting tools, things like that.
You had mentioned that Tekla doesn't really do a lot of that rebar detailing for that schedule out of the box, and you had to develop macros. Is that something Tekla did, or was that KGS?
It does the rebar detailing.
Just not that schedule.
It doesn't do auto-fitting the bar types to Canadian bent bar schedules. That's something that we did in-house at KGS for Hydro to match their requirements. So you can do stuff right out of the box, and it'll give you something similar to that, but it won't have all the Canadian standard bent bar types. It'll say, here's bar 1, here's all of its dimensions. And we could have bars 1 through 10,000 individually dimensioned, no problem, right out of the box. But to get, here's bend type B, bend type B2, bend type E, bend type F, and all the standard dimensions on them, that's something it didn't do exactly right out of the box. But to be fair, my experience with all BIM software is it does nothing useful right out of the box. If you think it'll do something for you right out of the box, you should realize that every piece of software requires planning. And that's not the fault of the software. That's because to make any complex tools requires you to know where you're going to get to with those tools and how to set up those tools. So one of the biggest lessons that we learned a long time ago was when you're getting into any complex engineering, architecture, design tool, realize that the first thing you should do is plan where you're going and how you're going to get there. So in this case, because it was very new, we didn't have anybody we could ask. In this week, we were more telling Tekla what we were doing, rather than asking them how we could do it.
And so the process in this case was that the software actually recognizes the shapes, but then you have to tell whether shape 1, what do you want to call it in Canada? So then that becomes part of the software. Like
Yeah.
that.
Further to that, out of the box, Tekla definitely, like Adam mentioned, the Canadian bend type standards that Manitoba Hydro had us follow, not something that Tekla does out of the box, although Tekla does generate bar schedules out of the box. One thing that we did have to do was the cast in place metric environment. It wasn't really there with Tekla in version 17, so something we developed ourselves. Very simple, but one of the steps we had to take. And then the bar schedules, and realistically, like it's all intertwined with the checking and the identifying of bar types. And Tero mentioned previously before about how we had, our checking procedure for these bend types. We had no individual bars; they were all groups. So while it looks like we've got there's a large number of bars in the model, they're grouped together. So you've got every different bend type. There's obviously a quantity of more than one. So
That was one of the big things that we needed. Because of the size of the structure and the number of bars, we needed to be able to lay up a large group of bars, because to have somebody go and individually place each bar along one of those curved surfaces would have been, it would have just been incredibly difficult. So we needed something that could parametrically handle not just the concept of the bar, but the concept of a group of bars with standard spacing over complex surfaces.
Yeah, this is a question, I guess, for all the designers in this room. But why isn't every project designed in BIM or 3D? Like, take a 100,000 square foot, 2-story box store. Is it still that much cheaper to do it in the 2D world?
I'll give you my answer on that. And my answer is, once you understand what you're doing, it's never cheaper. Our industrial group will no longer do 2D industrial work. It's not more effective for them to do it in 3D or in 2D. If you think about, I can draw a pipe and it's 2 lines and a couple of curves as it goes around an elbow, or I can draw an 8-inch pipe to my standard spec with flanges and valves and all the fittings, and I just trace the line. It's never more effective to do it in 2D. It's that it's difficult for people to learn, and it's difficult for people to change their process. This is a totally different tool than doing it in 2D. And historically in 2D, you may have had drafters working on stuff that were really good at drawing lines, but maybe weren't really good at designing. And like was mentioned earlier, if you want to get somebody to model something, if I want to route a pipe from here to there, I better understand the ramifications of routing that pipe. If I need somebody to reinforce something, I better understand the ramifications of how much cover, what types of hooks, all that kind of stuff. Now when we get into the details, sometimes I'm a little bit light, because I do a lot of this stuff, but by training I'm an electrical engineer, where we seem to have the least amount of BIM information. So that's my own personal gripe. I'd like to see more BIM in electrical.
Here's an opinion from an architect. Going into my 2nd decade with BIM, I started in 2002, had a practice that was driven down BIM lines, and I can tell you that in that time, on an average, 45% efficiency, a reduction from pre-BIM on design error on site from around 10% to tracking on an average about 0.8%. For the first time in my career, in 2008, I started making money in contract admin. So I would say, notwithstanding what they're seeing engineering, there are savings. There's huge savings to be made. Why is it not being elevated? The simple reason is clients aren't asking for it. They're the ones that need to make the change, not us. The minute they begin asking for it and demanding it, you'll see a change. At the same time, we have to change procurement. We cannot do traditional design, bid, build with this technology. It will not work. Nor can we begin thinking of P3s, which is just simply piss poor procurement. We've got to think of IPD and changing out and then using this technology. That's when you'll see all buildings using it. And I've always been asked the question, is there a certain size? No. I did a friend's garage for $200 for him, and I still made money.
And even in this case, I believe the KGS, if you had done the same project, same deliverables in 2D versus how you did them now with all the additional information, was it fast? Would it have been faster, or?
I think this was definitely, we were able to accelerate a lot of design things. When you're looking at a project like this, lots of the design is actually just interaction with the client. So this really helps you there. I think you're able to get to a better end product. I think you're able to shift design much more quickly and more flexibly with this. So I think that it definitely saves time.
Any more questions? Thank you.